Good day to everybody. I hope you are all doing good. No. So our next topic is that product or scalar product. That's our next topic. So previously we have discussed solving for the rectangular components of a force in 3 dimensions. No. So that product or scalar product of two intersecting vectors, it is defined to be a scalar quantity determined by multiplying the magnitudes of the two vectors by the cosine of their included angle. So the application of that product is when we are going to solve for the component of a certain force to a certain axis, no? So, previously kasi sa previous topic natin, what we have been doing is that we were solving for the components of the force relative to the x, y, and z axis. Now, what if it's a different axis? No, we are trying to solve for the component of a certain force to an axis or a certain line dun sa space. Hindi siya yung x, y, z axis. No. So, yun yung application ng dot product. Okay? So, we apply dot product to solve for the component of a certain force relative to a certain axis, o pwedeng axis, pwede rin namang relative to a certain vector quantity which is directed to a certain line segment, parang ganon. So, ganon yung application ng dot product. Okay? So, one use of that product is to obtain the rectangular component of one vector along any direction. Okay, so along any direction. Obtain the rectangular component of one vector along any direction. Okay, in space. Now, this component is equal to the dot product of the vector with a unit vector in the desired direction. From the figure, ito yung figure natin. So if you're solving for the component of the force A along force B, so if you are to solve for the component of force A along the direction of force B, we simply multiply the magnitude of force A to the unit vector. So remember the unit vector in the desired direction. So in this case, the direction of point B. So i-multiply lang natin. So ito lang naman yung kailangan nating intindihin. So the component of force A dun sa may force B. So we are trying to solve for the component of force A or vector A along the line of action of force B. We simply multiply the magnitude of vector A and the unit vector of vector B. So ganun lang kasimple. So what we need to know is the magnitude and the unit vector of the axis or the vector we are yung vector where we are solving the component of a certain force or vector. Alright, so properties of that product, it is commutative, it is associative. So commutative, associative, and it is also distributive. Okay? So the dot product of two vectors, so yung two vectors natin, for example, vector A and B, kunin natin yung dot product nila. Okay? So ito yung expansion so of course A and B, vectors A and B are expressed in their Cartesian vector forms. Ito yung expression nila in terms of Cartesian vector. And then kapag i-multiply natin yung dalawang vectors A and B, so ito yung expansion. So ito na yung magkakaparehas ay magkakasama. So ito basically this is the expansion of this dot product. And we will be ending up with this particular equation. Okay? Ito na yung equation natin. So yan. From the above result, the expansion of a dot product in terms of the scalar components of the vector is equal to the sum of the products of the respective scalar components. Okay, the sum of the products of the respective scalar components. Okay, so yan, that's how we solve for the dot product of a certain two vectors. Okay, so yun lang naman ang importance ng application ng dot product. It is used to solve or determine the component of a certain force relative to a certain axis or any direct or a certain axis, certain reference axis dun sa space. So yan. So yan yung application ng dot product. Okay, so let's try to solve some problems and to illustrate how do we apply this particular principle or concept. Let's try to solve number 1 in the exercises. Exercises nyo ito makikita. Sige, itry naman natin solve yung mga nasa exercises. Although may mga solved problems naman sa module. But let's just try to solve the ones in the exercises part. So number 1, determine the magnitude of the component of the position vector R along the OA axis. So this is the position vector R and this is the OA axis. So ano yung component niya along this particular axis? Okay, so ano kaya ang component ng position vector R along OA axis? So i-kukuha natin to, yung component niya. Ayan. So this would be the, so let's say that is R OA. So yan yung component niya along ROA. Along axis OA. That should be the name. Okay? So what we need to know, ang kailangan lang natin naman is the magnitude of the position vector R. So yung kailangan natin. Diba ang para malaman natin yung position vector or yung component ng vector na yan, ng vector R or the position vector R relative to axis OA. So that is ROA. It's equivalent to multiply the dot product of yung position vector R natin yan and the unit vector of this particular axis. So kapag yung direction natin ito, yung direction ng position vector natin, lipat natin, kukunin natin yung component niya along OA. So directed siya pa ganun. So obviously the direction also of that particular component along OA is pa ganun siya, yung direction ng kanyang component. Okay? So the dot product of the unit vector of along OA. Yan. So let's say unit vector N yata yung notation natin, N O A. So dot product of position vector natin R and then the unit vector natin along this axis. So what we need to know first, of course, is the coordinates. So kunin mo natin yung coordinates ng point A. Ano kayang coordinates ng point A? So x coordinate ng point A ay negative 6. Dito siya. Ito yun. Hope that is clear in the video. Negative 6. Y coordinate is, ito yung y coordinate natin. Positive siya, so that is 12. And the z coordinate is also 12, positive since upwards. And of course sa my O origin yan, so 0, 0, 0 yung ating coordinate sa my origin. And next, this point. Anong point ito? Ano yung coordinates natin dyan? X coordinate is, so x coordinate natin, positive siya. So 6. Y coordinate is, ang y coordinate natin is wala siyang y coordinate, so that is 0. And the z coordinate is 18. Ayan. Of course, dun sa origin natin, ang coordinates natin dyan ay 0, 0, 0 for all the axes. Okay? So, solve muna natin yung position vector, yung magnitude ng position vector natin. Ito. So, ito yung tail natin at point A, and this would be our head. Okay. So, how do you solve again for the position vector? So, R natin is equal to position vector natin. What is the position vector? So, again, head minus tail tayo. So, head minus tail. So, we have 6 minus negative 6. Ayan. 6 minus negative 6. Bracket na lang natin ito. So, 6 minus negative 6. Okay. I plus 0 minus 12. So, 0 minus 12. So, that would be minus 12j plus 18 minus 12. So 18 minus 12, so that would be 18 minus 12. Okay, so that would be our position vector R. So simplify lang natin. So that is 12i minus 12j plus 6k. So this would be our position vector. So okay na, solve na tayo dun sa first item natin. Ito, that is our position vector. And all of this, of course, are in feet. Yan. So yan yung distance na may direction. Directed distance, kumbaga. So yan na yung ating position vector. Next is kunin naman natin yung unit vector along OA, axis OA. And since na-project na natin na yung direction ng component along OA ay pag ganun, ito yung head natin, ito naman yung tail. No. Ayan. So, solve for the unit vector. How do you solve for the unit vector again? So, previously, ang notation natin for unit vector is U, pero just to be consistent with our module, ang notation natin ngayon sa application ng dot product is N. So, N. So, N OA is equal to ito. So, the position vector or the unit vector of itong axis natin na OA, unit vector. So, we are solving for the unit vector. That is simply the ratio of yung ating position vector, ito, along OA axis, yung position vector niya. Divide and yung distance between points O and A. Yan. So remember, this is the distance. Okay. Alright, I think we're good. So, NOA then. So, isolve muna natin itong R. By the way, itong R na to ay yun yung position vector ng OA. Yung ito na, yung OA natin na line, na axis. Okay. So, that's equivalent to, again, head minus tail tayo. Head minus tail. So, 0 minus, diretso na natin. So, 0 minus 6. 0 minus 6. I plus 0 minus 12. J plus 0 minus 12. 0 minus 12, tama. 0 minus 12k divided by the distance between the 2 points O and A. Okay, 2 points O and A. Square root of distance formula natin. So again, the same pa rin. 0 minus 6 squared plus 0 minus 12 squared. The square root of the quantity 0 minus 6 squared plus 0 minus 12 squared plus 0 minus 12 squared. So yung position vector ng axis natin, OA, that is equivalent to minus 6 tuloy. Okay, so 0, that should be ano, that should be 0 minus negative 6. Negative pala yung ating x coordinate sa my point A. So let's make it clearer. So 0 minus negative 6 dapat yun. So 0 minus negative 6. This is also true here. So 0 minus negative 6. Ayan. So 0 minus negative 6, so that would make this expression positive. So that is, okay, 6i, so 6i minus 12j minus 12k. Okay, so 6i minus 12j minus 12k divided by yung distance natin, divided by, so this would be 18. Okay. Ayan. I hope kita yan. So again, ang correction kanina dito sa ating pag-solve ng position vector, ito pala, position vector ng component along OA axis natin. So 0 minus negative 6. So negative 6 pala yung x-coordinate natin at point A. So that would make this term positive, minus, and then minus. Okay? So that's it. Next, so kunin natin yung ating unit vector. Okay, kunin natin yung unit vector natin. So by the way, this should be, kasi diniretso ko na pala kanina. Oh. So NOA na to. Hindi na siya yung R. NOA. So ito yung position vector. So this is, itong numerator natin is yung R. This is, the denominator is the distance between the 2 points. Okay, so diniretso ko na pala kanina sa equation natin. Okay? So the unit vector then is equal to, hindi pa yung red dito eh. So yung unit vector natin is equal to the dot product. The unit vector, i-divide lang natin bawat term sa 18. So that would be equal to, so 6i divided by 18 is 0.333, or pwede rin naman naka-fraction ito, ano, I plus minus 0.667j minus 0.667. Okay, so this would be the unit vector. And take note sa kapag nag-solve tayo ng unit vectors, the terms here should be always less than 1. So pag merong more than 1 dyan, kung mali na yung unit vector natin. So yung mga coefficient natin dito should be less than 1. Always, kapag unit vector ang pinag-uusapan natin. So kompleto na yung items natin para ma-solve natin yung component ng position vector R along axis OA. So, nasolve na natin yung position vector R. Okay? And then the unit vector along axis OA. Okay, so yung ating sorry, component along OA axis ROA is equal to malabo yata. The dot product of yung ating position vector kanina na na-solve and the unit vector along axis OA axis. Okay, so that's it. ROA is equal to, copy na natin, so this would be our position vector. So 12, we have 12i minus 12j plus 6k, that product. Yung ating unit vector 0.333i minus 0.667j minus 0.667. Okay, so mag-multiply lang natin yung magkakaparehas. Okay, 12 and then 6. So what we have now is, so multiply natin 12 times 0.333, so that is 3.996i. Okay, and then multiply natin negative, so this is plus 8.004j, but pag mas marami, pag naka fraction ito, this should have been 4, no, and this is 8. And then 6 times negative 0.667, so that would be minus 4.002. Okay. Okay. Yan na. So remember, sabi ko kanina, check natin. Ito yung expression yung kanina, ano? Yung derived expression ng dot product of two vectors. So, ulitin ko ulit para hindi natin makalimutan. So, from the result, the expansion of a dot product in terms of the scalar components of the vector is equal to the sum. Okay, take note, the sum of the products of the respective scalar components. Sum of the products of the respective scalar components. So, yun yung dot product natin. Dot product of two vectors. Which means that i-add natin lahat ng mga ito. Okay? That's equivalent to, we have minus 3.996. All of these are in feet, no? Kasi ito unitless or dimensionless quantity, ito ay naka-feet siya. Okay. This is in feet, ito naman ay dimensionless or unitless quantity. Okay, so this is in feet. Plus 8.004 feet minus 4.002 feet. So, minus yan. So, actually 4 ito, no? 4 din yan. So, wala na itong dalawang terms na yan. So, the component of the position vector R here along axis OA is equivalent to, so we have 8.004 feet, or this is simply 8 feet. Yan. So yan yung component along, the component of the position vector r along OA axis. So ganun lang ka simple. So dalawang major steps lang gagawin natin to solve for the component of a certain vector relative to a certain axis. Okay. Kunin lang natin yung position vector, or convert natin sa Cartesian vector form kung force man yan, kasi ito kasi ay parang directed line. So meron siyang direction na line. So position vector lang siya. So kung in case may force ito, may force yan. So solve for the Cartesian vector form of the force. Yan. Cartesian vector form of the force. And multiply it by the unit vector of the axis, or the vector where we are solving for the component of the force or vector quantity. Okay? So ganun lang kasimple. So hanapin muna natin yung position vector, ito, or kung in case of force, yung Cartesian vector form ng force, and then multiply it by the unit vector of the axis or the vector na kung saan natin sinosolve yung component ng force. Okay? Kung saan directed yung component ng force. Okay? So, ganoon lang ka-simple. I-apply yung principle or concept ng dot product. We'll solve another problem sa next na video natin.